big does an asteroid have to be to wipe us out? According to NASA, about 48 tons of space rock hit Earth every single day. Most of these are tiny fragments that burn up in the atmosphere, making a nice wish upon a star moment. But if that rock is just a little bigger, suddenly you're not making wishes anymore, you're running for cover. Take Chelyabinsk, Russia, 2013. A rock just 20 meters wide, about the size of a small house. It came in real fast, exploded mid-air, shattered windows, injured 1,400 people, but didn't end civilization. Then there is Tunguska, a 50-meter rock. It wiped out an entire forest. 80 million trees, gone in seconds. Still not a global killer. But move up to something 160 meters, things get a little more serious. That's about the size of Dimorphos, the asteroid that NASA smashed into during the DART mission. If something that size hit us, that's citywide destruction. Shockwaves, fires, possible tsunamis if it hits water. Now, let's say it's 1 kilometer wide. We're no longer talking about a bad day. We are talking global catastrophe. The crater alone would be over 10 miles wide and at least a mile deep. No survivors at ground zero. The resulting earthquake would easily hit magnitude 8 on Richter scale. The air blast would blow out windows more than 1,500 miles from the impact. If it hit New York, windows would shatter in Minneapolis. And then there is 10 kilometers. That's extinction level. That's the size of the asteroid that wiped out dinosaurs 66 million years ago. It's not just the impact that gets you, it's the after party. That would cause tsunamis on every coastline, wildfires across entire continents, dust would fill the atmosphere, the sky would darken, temperatures would drop, photosynthesis would stop, crops would fail, the food chain would collapse. It wouldn't just be a bad year, it would be the end of civilization as we know it. But here is the thing, size alone is not the only thing that matters. It also depends on what you're made of, how fast you're moving, and the angle of the entry. That goes both for asteroid impacts and other things. Let's break it down. The impact energy released by an asteroid is called kinetic energy and is given by this equation. Energy equals 1/2 mv squared. M is for mass, v is velocity. And notice, velocity is squared, which means that if you double the speed, you quadruple the energy. So yeah, speed, that's a big deal. Now let's imagine an asteroid that's 100 meters wide. Assume it's made of rock with a typical density of 3,000 kilograms per cubic meter. That gives us a mass of about 1.57 times 10 to the power of 10 kilograms. Now say it's moving at 20 kilometers per second, which is pretty average for an asteroid. Plug that into the equation. That gives us about 3.14 times 10 to the 18th joules of energy, which is roughly about 750 megatons of TNT. That's 15 times more powerful than the largest nuclear bomb ever tested. Now, swap that rocky asteroid with an iron one. Same size, but now the density is closer to 8,000 kilograms per cubic meter. That makes the mass about 3 times higher. And since kinetic energy scales directly with mass, the energy now jumps to roughly over 2,000 megatons of TNT. That's not 50 nuclear bombs. That's 40 of them, all going off at once. Basically, Bruce Willis wouldn't have made it. Another super important factor is the angle of entry. Yeah. If an asteroid comes in at a shallow angle, it has to pass through more of Earth's atmosphere, which means it might lose some of its energy or even break apart before hitting the ground. But if it comes at a steeper angle, 45 degrees or more, that's when all that kinetic energy goes straight into the ground. We can track these rocks. We can model the blast radius before it ever happens. We can calculate the impact energy. So yeah, we can actually use science and math to save our collective ass. So when people say, why are we spending money tracking asteroids? Just remember, it only takes one space rock traveling really fast with the wrong kind of attitude. I sleep better at night knowing we have scientists tracking this stuff. Because if we get hit and wiped out, it better not be because someone cut funding for these projects.